Hey, good morning, guys. I am hopping on here. Today is Friday, February 12th. We do have our online class for today, and my plan was to try to get through both of our remaining slides on our PowerPoint. If nothing else, at least through the first one. So in case, as you can see, super snowy back here, in case our internet connection is not good or something happens, I wanted to have this recorded for you. I'm going to go ahead and share my screen to take you back to our assignment. I'm going to do it through block 1, but you guys know, find the block you have with me, either 1, 2, or 3, science, social studies, and open it up. If you guys didn't join us yesterday and you see down here, this is just for fun. It's a link to a game about internet safety. It does, when I describe it that way, it doesn't sound super fun, but it actually is. But this is just for fun. You do not have to do this. That's just extra time, and you want to explore that, that's fine. Today, we're going to go back to Mystery Science, CER, and Race Right. Click View Assignment. I'm going to show it in Student View as soon as it loads here. And then I'm going to open it up in PowerPoint, I think is the right one. And I got to reshare my screen, or you guys don't get to see it. Okay, so when you guys open it, we've already worked on what animal has the biggest heart. The video was linked at the beginning where we first clicked into this. We talked about why is the ocean so salty. This one was a CER that you guys worked on independently, which means like on your own. I did explain it. We watched the Mystery Science together. If you have questions about this one and need a little more support, let me know. But this one, I wanted to see what you could do on your own. That brings us back to this slide, which was the same slide from a few weeks ago, our CER practice one. I am going to be making a poster that kind of shows how CER, which is what we've been working on, matches up with our race right. So restating the question, answering the question is the same as making a claim. Citing the text evidence is the same as finding evidence, and reasoning over here for CER is the same as explaining the importance of the evidence. So I highlighted them in similar colors so you can see how they match up. If you want to get a closer look, that's on slide 4 of our PowerPoint. Today my goal is to try to get through what is a black hole and why can't fish breathe on land. So with this one, what is a black hole? By the way, I do have the links to the videos inside of the actual PowerPoint. So you're going to listen to a Mystery Science, Mystery Doug, sorry, we're snow plowing behind me, that will explain what a black hole is. And then, then we'll go back over here and do a race right, which is basically a paragraph. You're going to restate the question, such as a black hole is blank, right? And you'll describe it. That would be answering the question, the blank part that I mentioned. Citing your evidence, which means referring back to the Doug instead of just putting the random facts that he mentioned. You would say, on the mystery Doug, or Doug said, blah, 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 and give like 3 pieces of evidence, and then you would explain your thinking. So I know that this is true because blah, 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 and basically we're just going to write our own little paragraph based off of what we learned in the video. So I'm clicking on the link right now, and I want to make it nice and big. So I'm going to go, I like to just copy the link. I know you guys have your fancy schmancy ways you like to pull that up, the little tech savvy friends, but I'm going to do it old school way. I just copied the link and I'll reshare my thing. Oh, my nose is all stuffy. I got winter allergies. How crazy is that? And then paste it right here. And then I do share it though, because I don't think I shared it with volume, and I don't want to do that to you. Okay, so what is a black hole? This one's about 7 minutes long, so I'm going to mute my mic during this so you can hear it really well. And then as soon as it's done, I will unmute and explain the rest of it.
Hi, it's Doug. This is the first ever real photograph of a black hole. Now, seeing this makes me think of all kinds of questions, like why haven't we been able to take a photograph of this before? Someone named Sammy has a question about this too. Let's give her a call now.
Hi, Doug.
Hey, Sammy.
I have a question for you. What is a black hole?
That is a great question. Well, I've got to tell you, this is one of the most surprising questions in science, because a black hole sounds like it might be a simple thing to explain. It's some kind of hole, right? But the idea of a black hole is one of the most advanced and maybe one of the weirdest ideas in all of science. For starters, a black hole is not actually a hole at all. It's an object, a thing. So, what kind of thing is a black hole? Well, at first, it was just something that scientists imagined could exist. It was just an idea, a what if. So, what's the idea of a black hole? Well, you know how the Earth has gravity, right? We think of gravity as the invisible force that keeps everything pulled down. You can jump up and get off the Earth's surface, but only for a second or two. Gravity pulls you back down. It's not that we can't escape the Earth's gravity. You know we can send things to space. But to do that, we need to go really fast. A rocket has to travel at a speed of nearly 25,000 miles an hour in order to get to outer space. We call this escape speed. Earth isn't the only thing in space that has gravity. Mars has gravity. The moon has gravity too. Now, because the moon is smaller than the Earth or less massive, it turns out the moon has less gravity than the Earth. If you jump while standing on the moon, you go a bit higher before the moon's gravity pulls you all the way back down to the surface. This also means that the moon's escape speed is much less than the Earth. Rockets don't have to fly as fast to escape the moon. The moon's escape speed is only about 5,000 miles an hour. Okay, that's the moon though. What about an object more massive than the Earth? If you could stand on a planet bigger than Earth, the gravity would be stronger. You wouldn't be able to jump as high as you can on Earth, and the escape speed would be even more than the Earth's escape speed. This is where the idea of a black hole comes in. Scientists ask themselves, what if there were an object so massive, an object that had such strong gravity that not even the fastest thing in the universe would have enough speed to escape it? Let's think about what this might be like. What even is the fastest thing in the universe? Before I say anything more, try to take a guess. Now would be a good time to pause the video and discuss. Okay, you ready? The fastest known thing in the universe is light. Maybe not too surprising, right? When you turn on a light switch, the time it takes for light to go from the light bulb to your eyes seems like it happens instantly. What if there were an object with such strong gravity that its escape speed was even higher than the speed of light? Would that mean even light itself wouldn't be fast enough to escape this object? If you think about it, you can start to imagine why the name black hole makes a pretty good name for this idea. It would be like a hole because an object like this would have such strong gravity. Anything that got anywhere near it would get sucked in towards it. A passing spaceship, nearby planets, entire stars, maybe even light itself. If light couldn't escape an object like this, think of just how weird that would be. Imagine if you could stand on this object with a flashlight. You go to point the flashlight up to shine it into space. But the gravity of the object would be so strong that the light wouldn't even be able to go up. It would bend back and fall toward the ground beneath you. So the object itself would have to look black. It would suck in any light that got near it. Now, like I said, at first, all of this was just an idea, a what if. If such a thing existed, would it really do that to light? Can light really be bent? But around the middle of the 1900s, scientists discovered some reasons for thinking that black holes might actually exist in real life. They started looking for them using telescopes. But as you might expect, one reason why it'd be hard to see a black hole is because they're black, and so is outer space. But it should be possible, especially if there's a black hole sucking in material from some nearby object, like a star. Maybe we'd see a bunch of light getting sucked into a kind of black spot and disappearing. Using telescopes, scientists started finding places in the universe where they think some black holes might exist. None of these places are anywhere near us, which is good news. We wouldn't want to get pulled into one. But this is also the main reason why it's been so hard to actually get a photograph of one. Even though a black hole is a massive object, they're all so far away from us that scientists realize we would need a telescope the size of the Earth itself just to be able to see one. That is what's most amazing about this, the first ever actual image of a black hole. A team of 200 astronomers worked together all around the globe and used 8 different telescopes to basically act like one giant Earth-sized telescope. It was not an easy thing to do. Not only did the telescopes all have to point at the exact same place in space, but to combine the view from each telescope involved really advanced computer skills used by scientists like Katie Bowman. Now we have photographic proof. Black holes aren't just an idea, they're a real thing. What other kinds of strange things will we be able to discover by combining telescopes like this? Will we be able to actually see other planets like Earth going around faraway stars? Will we be able to find other things we've only imagined could be real in movies and stories? Things like wormholes, passageways that take us to other parts of the galaxy. One thing's for sure, it's an exciting time to be alive. That's all for this week's question. Thanks, Sammy, for asking it. Now, for the next episode, we're going to do something a little different again.